Hmm. Okay. Have I guess we should have around 40 students in this class, right? 25 online and probably some of you like on in the lecture room. So let's expect at least more than 20 response here before we move on. Yeah, just for your information, I checked. It is well, it's around 10 degree, 10 Celsius degree in my place. It's getting to later part of autumn here in Norway, and yeah, it's usually cold. So I hope you don't feel too bad if it's hot there. And okay, I see a lot of, positive energy in the room. You see the text, it's look big. I mean, it's repeated many times for this word cloud. Okay, so many people feeling well and exciting. That's good. If you're hungry, maybe you can finish your lunch. I have no problem with that. Hmm, okay, good. Um, let's move on to the next question. So I want to understand where you are in this course. So you already have your crew and you have the capstone project, right? Printing service for the university. So that's you. You have five milestones. The first one on requirement engineering, and you draw a use case diagram too. So let's see what you have done with the milestone one so far. Okay, so interesting. The one doing others here. If you don't mind, you online write down the name of the tool you use as others in the chat. But most of you using draw.io, two of you use Lucy Chart. Why draw is a very convenient tool to draw anything. It's basically is like new version of Visio, right? That's the Microsoft tool set before. But I think you have to start from scratch for even a diagram. We have software like Rational, Software Modeler, or Visual Paradigm. They are more professional. They are dedicated to UML background. Let's see. Okay. So you correctly. Okay. That. Thank you. Okay. This something like Lucy Chart. Uh, I think they work fine. But I used visual diagram back then many years ago, and now they have the net versions. Very good, good templates, easy to draw, and more importantly, they have very comprehensive tutorial. I like that. So we will practice with user diagram paradigm in this course, and yeah. They have free account, which should be sufficient for my lectures. Okay, thank you. Let's move on. Milestone one, don't know. So you can tell me what kind of relationship you use in your use case diagrams. Listed our own possible kind of relationships. The most basic one is that just an association link between an actor and a use case, right? Yeah, very interesting. Yeah, of course, everyone would have the first one, the link actor to use case. Generation is say when you have one actor as a specific type of another actor that you want to highlight because they have probably some use case that the general one do not have. Extension means that one use case extend the behavior of another use case. And inclusion, that means one use case will include another one, and generalizations. One use case a subset of another. So quite a lot of you have the inclusion and extensions relationships, which are very good. So the more different tied up relationships you try, the better you learn about them. Very good to see that here, better than other lectures. Okay, and next question. Do you have an alternative flow in your use case description? Okay, we have more people online now. Um, I think it's described as in the project descriptions. So I think it won't be normal if you have an alternative flow, like it's a if then else, right? In when you go with logic. So maybe you do not see that. Probably that maybe you miss something there. Very good. Let's get to the next one. Now let's get to some open question. Um, okay, so let's say in a smart printing systems, and you have use case called select printer, and you have students, you have printer as actors. So what's probably wrong in this description? right? Very good. So, I think we have the same answers from okay, it's keep coming. Very good. So eight response here. Okay, I really like the interaction in this class. You're really engaging. And all of these are correct. So printer should not be an actor. It should be an object in these systems. You can represent it in a context model actually later on, but in use case diagram, it shouldn't be shown as an actor. Okay, so next question. We will learn about class diagram next week, but perhaps you have some ideas about it already. Um, Yeah, you're supposed to know about object-oriented programming to really fully understand the class diagram. Because that's first we assume that we model our system following object-oriented style, capturing the instance we can observe in this real world. Everything is objects, and object have like properties and have behaviors, right? So in a class diagram, what can be wrong if we have this relationship? Yeah, have a first one and keep coming. Well, okay, so in the OOP, object-oriented programming, an object can be anything. You can be a human, you can be animal, you can be a car, a bicycle, a printer, so anything that have properties and can do have some function. Everything will have some functionality. So everything basically are object. But the thing is that I think most of you are correct here that they don't share common attributes, and they are not also connect any logic as inheritance. Like uh, printer is not a special type of students and not the other way around. You can have, for example, a person class, and then you have a student class, and then we can say student can be inherit from a person class, right? Own attributes of a person as a student will have as well. but not happen between student and printer. Very good. Um, so last but not least, how do you judge yourself regarding your knowledge with these diagrams? This is the name of the UML diagram, so we will learn about them. This is my lecture. Okay, it's quite interesting that you can see as well yourself overall very good confidence of class diagram is compared to other kind of diagrams. Huh. We haven't started with this, and see, yeah, it's more than five above the average. That means that we'll have an exercise on class diagram next week. But yeah, maybe if you will get it done very quickly, I have another one on activity diagram or state diagram. It's okay. We go through sequence diagram today. But yeah, I can tell you a bit about activity diagram too next week. All right, thank you. Let's get my slide start. So we will bring to you mm, different types of models: context model, interaction model, structural models, behavior models. And in the end, we will talk about model-driven engineering in these two lectures. But okay, but first of all, what is system modeling, right? Yeah, um, is defined as a process of creating an abstract views of systems, and each model, uh, each perspective will capture a different view on the model. Uh, Easier to remember. So think about this as when you building a house, Yeah, it's you start with first the architecture of the house, right? Someone draw a blueprints of the house showing the structure, how many floors you have, and how many rooms and where are they. And you will need another view on the electricity systems, right? How to implement the on a wire system connecting through on the floors. You will also have water systems, like how to run water pipeline through kitchens, living room, toilet, gardens, etc. So that show you different views, and all of them are necessary to build a functioning house. Um, People love visual representations, and we usually use kind of a graphical notation for modeling. There's a different modeling language out there, but it's safe to say the most popular one and standard one is UML, Unified Modeling Language, becomes standard in many countries. So it's safe that you learn how to use that, how to draw them properly. With such system modeling, it helps the analyst to understand the functionality of an existing system. It helps to communicate with customer, right? Someone who don't know the technical detail, to managers who want to know the scope and some details of the systems. To talk to engineer where they would love to see as much detail as possible. So different level, different fine grain level of a model that you can build. And so you can capture either a new system, you explain the requirements and go further from that to capture some design aspects with these models. But you also do a lot of modeling of existing system to clarify what the existing system does, what can be improved, which lead to the need for the new systems. There are four views on systems. The first one is context or an external view, showing your system in its context, in its environment. Interaction, it show how the interaction happens between the system and its environment, or between the components of the system. Structural perspective, it captures the organization of the systems, the structure of data, structure of code, files, and behavior show, I mean, the dynamic perspective, how the system responds to an event. In some cases, behavior aspect more interesting, like traffic light, right? How to move from red to yellow to green lights, how long and possible interruptions. Um, the graphical, the charts, the diagrams here is important thing to capture the discussions. It's also important way to document the system. You will see the system description or the design documents. They are full of UML diagrams with their description, of course. And for with a detail enough models, those model description can be used to generate the code to generate implementation. And this is more and more straightforward these days with generative AI. But first and foremost, these models should be correct and complete. So there's a whole research on formal verifications, yeah, applying formal method to prove the correctness of these models. And that is more easy to generate it these days. Okay, now I talk about different UML diagrams. As listed the name before, but you will see they it can be confusing. They're different UML diagrams. There are also different system perspectives. Are they mapping one on one? So they technically no. So UML diagrams can be used in different scenarios, and one UML diagram can be used for context modeling or interaction modeling in both cases. Activity diagrams it show the activity involved in a process. Sequence diagram show the interaction and the sequence of these interactions also in a process manner. Use case diagram show the interaction between systems and its environment. Class diagram is more straightforward. It shows the organization of object of classes. So it shows a structural perspective, right? And state diagram show how the system reacts to internal and external events. Yeah, it captures the dynamic behaviors of the system. So yeah, so usually you use a certain type of UML diagram or to capture one perspective, one system perspective. So we talk about the external perspective first. So you draw a context model to illustrate for the operational context of a systems. And the most important thing here is to draw the boundary, what inside, what outside the systems. This is one example of a context model. You can find this example in the Ian Somerville book. By the way, it's the textbook for this course. The slide view on top of the material there, and by more detailed descriptions in the book. Here you see it's quite simple with the context model is several boxes and the link connecting among them. First, you see that the main care have connection to other systems here, and that's where the API, the external interface, should be built. Second, you see that obviously man care don't do patient record management, don't do admissions, don't do prescription, don't do appointment, don't do management reporting, right? So it clarifies what is in and out of this system. So it helps a lot to discuss social and organizational concerns when to position the system boundary. And it gives you a very beginning of architectural view on how you should start design the systems. Sometimes in some case, you want to even specify the role of the to be built system in a larger workflow. In a bank, in logistic, where you have a more complex workflows and you want to show detail the interface of the current system, and with those, of course, that is the environment, but it gives you more information helping to build that. You can use, for example, activity diagram here. So activity diagram, you start with this solid circle, right? That's starting point, and you end with the circle with the peripheral line here in the end. Start from confirm detention decision, this activity, and this going through a sequence of activities, right? And it can have the loops, the branch, and then go to the end. Okay, but what we say here is the systems man care. They have the interface two places in this workflow. So then we know that we have to divide external um two external points here. All right. We let's have a break, like 10 minutes, and after that, we get to the next part with interaction perspective. Okay, should we continue? We talk about context model, and yeah, it can be quite simple to draw a context model with boxes and a link, right? And now we talk about interaction perspectives with two kind of model, use case diagram and a sequence diagram. So you can do the interaction models at different level for different stakeholders, right? We have user level where you can model the interactions between users, help a lot for identifying user requirements. You can do it at the system level to capture the communications between the systems to define the external APIs and to capture potential cross-system problems. To model component interaction to understand how how the system structure likely to deliver its performance and dependability among them. And use case is one on diagram for this. Yeah, we know what use case is, and it's used a lot in requirement elicitation. And it's also used in architectural view. If you know the 4+1 view of the architectural, so the one here is the use case diagram to capture the context. It also used here, and we show how we can capture the interactions. Okay, so in this memory care use case, we have everything here to describe the use case of the memory care systems. We should draw a rectangle box to show the boundary of the system too. Is missing here. But beyond that boundary is patient record system stored as another actor. So in this picture, then you see the interaction right, between medical receptionist and the patient record system via what is called a use case transfer data. Yeah, and you can do in the same way, and then you can draw for other use cases for medical receptionist. Use case diagram is usually insufficient, so that's why you need also use case descriptions, and very common to have in a table. It is systematic, and it's good when you have a lot of use cases. It's an example of how we describe an use case with this structure. So the use case name is search club event. So it's one function you can use in a university page. So the preconditions, yeah, in many functions, you are required to log in. So it can write like you are logged in, so you're able to do that. This one is more simple. You only need to connect with internet, and you are accessible to the university homepage. So the normal flow describe how this use case carry on. It shows the interaction between the actors and the systems. You can see like number 1, 3, 5, right? These are the users, and number 2, 4, 6 are the system response. The alternative flow you can make for the whole flow, right, on the stage, or you can make for parts of that. Like here, like at step 3, they make a branch like 3A or 3B here. Okay. So that's about use case diagram. So the central of interactions on the model is a sequence diagram. Of course, it's a type of UML diagram, and it shows the sequence of interactions. The more important thing is the temporal time, right? The time, what happened first, what happened after, right? That's why it's a sequence. So the object and actor involved are listed along the top of this diagram. Each of them had the dot line. I draw the lifetime of each of them and the interaction draw between these lines. I can show you an exact example. So let's say here a bit. Um, so you can look at this first and to try to understand the logic without my presentation. So what you see in this diagram is the description of the use case enter wrong account information. We start with the user who insert his or her card into the ATM machine, and after some time constraint, let's say it's correct, then the information is sent further to consortium, and consortium will verify the account by sending it to the bank. So wrong information, so account's not okay, flag sent back to consortium. So the back message is shown as a dash line, and the dash line from consortium back to ATM, and from ATM back to user. So the components or object is shown by the boxes here, right? ATM, consortium, bank. You don't need to have it in different colors, but they should be in the same shape for the same thing. So user is the same from use case diagram. You have the lifeline as mentioned. It's a dash line, vertical dash line represent the time when you code this, it show the time when you start initiate the object until the time you finish and collect the resource assigned to the object. And you have also during this time is the activation line. So it's shown by the rectangle boxes, blue for the components and pink for the actor. And it show where the component are actually active, used, or waiting for response or doing something. And it's some special thing. Yeah, you can read on this from the tutorial for drawing the sequence diagram from the visual paradigm page. And most important thing is the message. So the message go from one side to another side, and when you implement it, it is a function call. For example, ATM will call the functions to consortium, and consortium call function of a bank. So the sequence, yeah, you see that the things that on top, is the things happen first. Then the sequence go from top to down. It's the sequence of the activities. Okay, so enough to listen, and now get you some hands-on work. Go to this link, tinyurl.com slash system modeling MITI 1. So each of you should on one page, one slide page here, so you can change the name here, student one or student two, to your name or to whatever you want. So yeah, I reserve some space for you. And the description of the task is on the first page. So this is an use case taken from our project about smart urban waste collection management systems, like the software support for nhân viên môi trường là lao công to help them do better job in a more easy way. So in this project, there's a person called back office who sit in office and monitor the software. So what the back office do, like they were retrieve information about the collectors who will actually collect the garbage from a list, and select an area for collecting, and identify the what is called major collecting points. This is the area where we collect the garbage from ngõ hẻm, phố, small streets, right? And it's called điểm tập kết, right, in Vietnamese. And then from there, the truck will transfer the garbage to other locations. There's a route on how what is the best way the collector can go to collect the trust. Uh, uh, and in this use case, this describing the process how we can assign a new task to a collector. Okay, still not many people are here. Can wait a bit so you can get access to this. Show you here, and I can put this on the chat as well. System modeling with double L, BT1. You can find it in the chat, in Zoom chat too. Um, as you don't know the domain, and I prepared the second slide where you get even more descriptions. It's a list of actors and a list of messages already. So the tasks become more simple, right? I put them in a more, oh, yeah, someone already made something, oh, very fast. I will have a look on this. It's doesn't like it's yeah, it look like, yeah. Well, if you did yourself or you make it generated, this is something that we can talk further. But um, the purpose of this exercise for you to practice. So even that you can generate it, you should still, I mean, do it yourself. So you get yourself familiar with the notations, with the template of a sequence diagram. So create an account with a visual paradigm and start from scratch and create things. Save as a picture and upload it like the first one here I've done. Oh, let's say we come back in 15 or 20 minutes. Okay. So you have enough time to practice with this, and I will correct. I'll give you feedback if you are able to put your diagram here. I'll show my screen again in 15 minutes. Hmm. Okay, we have only one who are able to submit the diagram. And let's see. Oh, okay. See a very hardworking student in the classroom, working on something like making a diagrams, I think. But let's spend 1 2 more minutes. We need to go back to the the slides and I won't comment on what's wrong or with submissions. Think we have two submissions now. Okay. So the task is to draw sequence diagram for the use case assign task to collector. No. Okay, so this from the first one. So he make 4 components. Put the back office staff and collector in one of the end. Um, okay, so with this is one thing that you overload the back office staff because the owner message go back to the back office staff, meaning that he have to deal, he need to manage all of this information. So it's an opportunity for some kind of like automation. So it can go sometimes go from one module to another. So then it don't have to go directly to the office. And then you can have less number of steps and more simple scenario for back office stuff, right? Um, oh, I think we have more. No, no. Okay, so this one is also done by a previous student that and it's my favorite because you see the back office they require and retrieve the list of the collector and select the area and they get the route as well that's in the same interface. And after getting the collector, after getting the route, and they do the assign the route with the time and vehicle, and that's we create object collector here and do the assignments. Uh, so you see every out message it will have a corresponding in message back. Yeah, so this is something similar, but this do everything back to the back office. This one. Okay, so let me see if we have more. Um, okay, we have more, so we can go through this again. Let's look at this here. Yeah, that's correct. And yeah, maybe the activation line of you can make it longer for overall for this objects. Especially here, we have the same activation line between area selection module and major collecting points, right? That it can be, but the area selection module need to be created before, right? Before the major collection points. It should show that. Okay, it's a question from Ming. The backward arrow. If you implement with code, it's it is a return variable. So you call for a function and the function return you some variable, and that's the meaning of this backward arrow. You request for the root, right? For example, going from the back office to scanning module. So then we expect the module scanning module will send back the root, and we need to make it explicitly, and that's why for every forward arrow, if you expect a return message, you will always have the backward arrow. This one is yeah, this one is more correct because even that when you assign a root vehicle time from back office staff to the collector, you should also get a message and back like it's like okay, I mean the task is already successfully assigned or not. This is the one that I can put this best answer. Well, you get certain points. I think all of you who are able to drop uh, uh, um, drop an answer here, you get, I mean, so it's more than 70% at least. Basically, you use the right annotations and the structures and even something like this is not wrong. It's only you're only missing the final, I mean, returning arrow back from the collector to back office staff. Yeah, but then I think this is almost a 9.5 out of 10. But this would be the best one. Yeah, I put here slide number 4. Very good, but I really like that there's a lot of questions and stand opinions. Wow. Um, you can also put your question here since we're going to the last minute. Yeah, go back to the menti.com and you will see the new question. So you can put your question here. In the meantime, why request root informations don't start at the back office? Okay. Uh, um, okay, so here the root information can be requested implicitly when you do the selecting area. So so this nothing wrong with this when you have the when you have the root request starting from the back office staff. What I did say is that then it will overload the back office, and in this scenario, it will show a lot that come back to in and out the back office. So in another way of implementing this software, you can automatically generate the route by when you're selecting the area and identifying, like during the selection you identify certain points, and the available route will be generated based on the selected points, collecting points. So it's not that's why it's not nothing wrong with this. When you say it up from the back office staff, that I just want to show the more the sequence here going through different components, so I prefer this one. But there's nothing wrong when you do it in this way. Let's see. Uh, how can we draw an object in use case diagram? So in use case diagram, you don't draw an object there, like the printer, right? In the question I asked you for the printer, it not treated as an external system, so it will not play a role as an actor. So it will be shown implicitly. It will be part of some use case, but you do not draw an object there. Use case diagram is tend to be very sketch, very generic. It's not complicated, and then you yeah, you show the context, and for more detail, then you do sequence diagram or activity diagram. Very good question. I like the best answer because of the interaction between modules. Yes, that's correct. But it will depends a lot on how the system are required and how the system are designed to draw. So it's not better that uh, you have the implementation with each module, then everything come back to the actor. It's about the way you design the systems. And here the interaction, I want to reduce the load on the users. So we shift some of that to be automated and done by a module. So in practice, because in this project we run it actually, and that's the scenario where the user like to have. It's less things they have to select from the screen and more suggestion and more automate parts. Um, for your question, you need to conduct also research study on the user experience. What is the best way to design the interactions between the users, the actors with the system, right? You need to also study the system functionalities. If it can afford a level of automation, so some tasks is not manually done, it means that less interaction between user and the system and can be captured between the modules instead. So what is an okay? What is an actor? When we draw use case diagram, you have to come back. We don't have time for go in detail this, but go back to and read more about use case diagram. How you can define one as an actor. It should play a role, right? And an actor is like a human or like a system. It should perform some use case. Printer in this case is just a device like a mobile, right, or a TV. Can you have a TV as an actor in the use case diagram for printing service? Right. So think about that. Read more about how the actor should be defined. Very good. Um, I can talk about the question. The you going to become a software engineer. I love this topic, and absolutely I will come back with this. Remind me next lecture if I do not start with that. But I would love to give you 10 minutes of my view on how you should build your career as a software engineer. Yeah. Yeah. Okay, with this, I think we can close the lecture today. Thank you, everyone. Okay. So more people. So yeah, of course, I will give you my thoughts on that, and we do it in the beginning of the next lecture. And now, should you enjoy the weekend? It's Sunday anyway, so have a good day.